Hello, my dear students. In this lecture, I am going to explain the transmission lines, its type, and the equation for the voltage and currents, and surge impedance and surge impedance loading. These things I am going to cover in this lecture. Before starting, I want to tell you that transmission line have three parameters. Basically, resistance, inductor, and capacitors. Resistor due to the resistivity of the transmission line, and inductor due to the current flowing through the conductor, and capacitance. This appears due to the earth, and transmission line. I have explained the effect of earth on the capacitance and also inductor in previous lecture. Now, the types or classification of the transmission line depend upon the frequency and length of the transmission line. You can see here, if the FL product of frequency and length of the transmission line is less than 400 Hertz kilometer, then this line will be called as short transmission line. And if the product of the frequency and length of the transmission line will be lie between the 4,000 and 12,000 Hertz kilometer, then it will be called as medium line. And if the FL frequency and length product will be greater than 12,000 Hertz, then it will be called as long transmission line. If you calculate, if you put the value of the frequency 50 Hertz, then this length will be simply for the short transmission line will be 80 kilometer. Yeah, length of the transmission line in terms of the length only will be 80 kilometers, and for medium transmission line it will be lie between 80 kilometer and 240 kilometers. And if the length of the transmission line is greater than 240 kilometers, then this line is known as a long transmission line. Now, how the length of the transmission line changes the behavior of the transmission line, or the some parameters can be neglected if the length of the line increases. Right? Suppose this is the transmission line circuit model, and the resistance in series, inductor, and here the capacitor. This is the second part. In this way, the transmission line, if all these parameters are distributed throughout the transmission line. Suppose 10 ampere current into this sending end, and there is 10 ohm is the resistance and 10 ohm is the capacitor. Series impedance is 10 ohm. Also, 10 ohm is the resistance of the capacitor. Then you can see several these small sections are connected in series. In this way, we can say that this 10 ampere, when it's passed through this transmission line, 1 ampere will be bypassed through this shunt component or the admittance, that is this electrical equivalent will be capacitor. And you know that the impedance of the shunt shunt path is will be equal to 1 upon j 2 pi fc into L, right? Why it is you have heard already about the ZSH in case of the capacitive path or capacitive circuit will is equal to the Z C equal to was equal to 1 upon 2 pi fc, but here is multiplied by L because this is Z equal to 1 upon 2 pi fc is the per unit length impedance, and there will be length L, then it will multiply by L. Okay, and now hence this is the ZSS impedance of the shunt path, this shunt path. Okay, now if we calculate the admittance Y, this is shown in yellow color, Y will be equal to the J 2 pi C 2 pi FC into L. 2 pi C has been taken as a single unit and FL is another unit. Then we can say that admittance is directly proportional to frequency and product of the frequency and length, and impedance of the shunt path is inversely proportional to the product of the frequency and length, right? If this F or the frequency or length of the transmission line will be increased, then impedance of the shunt path will be decreased. Okay, जब इस ट्रांसमिशन लाइन का फ्रीक्वेंसी और लेंथ बढ़ेगा, उस केस में इम्पिडेंस जो क्या होगा इस पाथ का घटेगा, राइट? जो शॉर्ट ट्रांसमिशन लाइन होता है उस केस में ये सारे जो शंट ब्रांचेस है ये अपीयर हो जाती हैं, ठीक है? बट इन केस ऑफ लॉन्ग ट्रांसमिशन लाइन ऑल दिस, जब ये आपका जब F और L, F तो 50 हर्ट्ज कांस्टेंट होता है, लेंथ जब बढ़ता है तो आपका ये ट्रांसमिशन का इम्पिडेंस क्या हो जाएगा, डिक्रीज कर जाएगा, या इम्पिडेंस डिक्रीज कर जाएगा, इसका मतलब ये आपका नेग्लिजिबल नहीं होगा, ठीक है? बट इन केस ऑफ शॉर्ट ट्रांसमिशन लाइन दिस इज नेग्लिजिबल when L will be and L will be almost 0, then this will be ZSS will be almost tends to infinite, or it will be highest. Okay, then this path will be highest impedance. When this path will have highest impedance, then the current passes through this will be very minimal or less or negligible. Okay, in case we can approximate it as an open circuit in case of short transmission line. Okay, you have to be careful about this type of transmission line. You have to remember all these criteria in terms of product of frequency and length, and also in terms of the length only. Okay. This is a numerical. This is numerical of from gate. A 10 kilometer long line is operated 500. You can see very carefully. This is 500 hertz. If is modeled as, then what will be the type of the transmission line? It will be short or medium or long, or data is insufficient. Thus, you can calculate using by putting the value F is given 500 hertz and length is 10 kilometer, then FL will be 510 kilometer, and product of this will be 5000 hertz kilometer. This means 5000 hertz will be lie between 400 and 1200 hertz. This means it will be medium transmission line. In many books, these transmission line classified on the basis of the length of the line. But if you don't know, the classification of a transmission line is estimated on the basis of the product of the frequency and length of the transmission line. Hence, you can do mistake. Hence, you have to be very careful. These notes and notes is very important for you from the gate point of view. Right now, let us consider the long transmission line. We will calculate uh, voltage and current equation for the long transmission line by considering a small section of the transmission line. Suppose this is a transmission line given here. This is sending end, this is receiving end. Sending in voltage is Vs and receiving voltage is Vr. Sending in current is Is and IR. And this receiving end voltage taken as reference. Okay. Sorry. Reference voltage. And when you will move from receiving end to sending end, voltage will be increased, because this is sending end or generating end. When the voltage transmitted to the load, then voltage drop due to the resistance or inductance of the transmission line, right? Hence, you can say that when you move from right to left, this voltage will be increased, right? Due to which we have taken point, reference point at x distance, and again at delta x section, the resistance and shunt branch and series branch has been taken as this way, right? We have taken separately this delta x section. If the per unit impedance, series impedance is Z and per unit admittance is Y, then for the delta x will be, this impedance will be Z into delta x, and Y into delta x will be the admittance for the shunt section. Okay. If the voltage and current at the distance x is V and I respectively, this will be V plus delta V and I plus delta I at the distance x plus delta x respectively, right? If V and I at x, the voltage and current at the expression will be V and I, then it will be at delta x, it will be increased delta V, delta I in voltage and current, right? Then this delta y can be written as Vy delta x. Y is admittance. Y delta x is admittance for the delta x section. Hence, delta I will be V into Y delta x. If it will be impedance, then it will be divided by Z. But it is admittance form. Hence, delta I will be V into Y delta x. Similarly, delta V will be delta V. This delta V will be what? I plus delta I this current into series impedance of this delta x section, that is Z delta x. It will be equivalent to I Z delta x. You know why it is neglected? Delta I and delta x multiplication will be again very small, due to which it is neglected here, and it will become this delta V will be equal to I Z delta x. You have to be careful. Remember this, delta I and multiplication with delta x will be very small, hence it will be neglected. Now, ratio of the this equation 11.38 can be written as delta I V delta I divided by delta x. From this will be equal to V into Y, voltage into admittance, and this delta V by delta x, from this equation delta V by delta x will be equal to I Z, I into the delta x shift will be transferred here. It will be equal to the delta v by delta x equal to I z. Now you can consider section delta x very small, then it will be it can converted into the di by dx will be equal to simply v into y. Similarly, dv by dx will be equal to iz. Now differentiate again equation 11.4 this one. d2v by dx square will be simply di by dx into z. This di by dx can be written as from this equation vy, it will be equal to v by z. Now 11.4, this equation can be written as in exponential form. A exponential root yz plus b exponential minus root yz. And this again written as e to the power gamma x, where gamma is the root yz. And this is plus b plus minus y minus gamma x, right? This root yz is known as a propagation constant. You have to remember it. Will be equal to alpha plus j beta, where alpha is the attenuation constant and beta is the phase constant. I think this thing you have been read in EMFT, electromagnetic field theory also. Okay, and this is also the wave equation in transmission line. You have to remember it as wave equation, and where gamma will be equal to the root yz. Y is the admittance, z is the impedance. Okay. Now dv by dx will be, from this equation dv by dx will be simply a gamma will multiply by both, and it will be equal to the iz from the equation. This one dv by dx was equal to iz, right? From this equation you can calculate I equal to 1 by zc. Here z will become zc because it's considered as a characteristic impedance, and remaining things are same. Now using limiting condition, if we put the limit to calculate the constant a and b, limiting means if we put x equal to 0, x equal to 0 means receiving end. At receiving end, voltage was VR and current was IR. Then we will get VR equal to A plus B. If we put the x equal to 0 here, and this will be e to the power 0 will be 1, and this become A into 1, this become B. Okay. Then VR from this VR will be voltage V will become VR, and this VR becomes the A plus B, right? Similarly, I will be IR will be A minus B by Z. After putting the values at limiting condition, we will get VR and IR, and it will be equal to this one. And now we will calculate A, value of A from these two equations A and B. Then we will get A equal to VR plus IR ZC by 2, and B will be equal to VR minus IR ZC by 2. This equation and this equation 1 and 2. This equation, if we solve these two equations of variable A and B, we will get the value of A in terms of receiving end voltage and receiving end current and ZC, and we will get VR plus IR ZC by 2, and B will be equal to VR minus IR ZC by 2. Now putting the value of these value of constant in equation 11.41, this one, and then it will be equal to this. And after solving this equation, it will be like this one. e to the power gamma x plus e to the power minus gamma x by 2 plus e to the power gamma x minus e to the power minus gamma x by 2, right? V will be equal to VR cos hyperbolic gamma x plus ZC by VR sin hyperbolic gamma x. Why? Cos hyperbolic gamma x will be equal to e to the power gamma x plus e to the power gamma x. Okay. This section will be equal to the cos hyperbolic, right? And this minus e to the power gamma x minus e to the power minus gamma x by 2 will be equal to the sin hyperbolic gamma x, right? You have to remember this formula. Now I will be equal to similarly where it's sin of hyperbolic gamma x plus cos hyperbolic. Where there will be minus, it will become sine. This will be sorry. Right. This is the minus section will be equal to the sorry. This will be equal to this sin hyperbolic. If there will be minus e to the power gamma x or e to the power x minus e to the power minus x by 2 will be sine hyperbolic, and there if there is a plus e to the power gamma x plus e to the minus x by 2, it will be equal to the cos hyperbolic. Similarly, we will get the value of the I dr by ZC. There was already ZC. This becomes minus sine, it will become sine hyperbolic, and plus sine it becomes cos hyperbolic, right? These are the equation. What is the current equation? Again, it can be simplified in this way. Now we can calculate the sending in voltage and current equation can be obtained by putting the value of x equal to L. When instead of x equal to 0, if we will put the value of x equal to L, then we can achieve the value of the sending end voltage. Okay. At this point, sending end voltage, this value of x will be equal to the value of L, length of the transmission line, and we will get similarly Vs and Vs, Is like this. Now comparing equation 14, 11.47, 11.48, we can see that A constant, this coefficient of A and into VR and IR coefficient, this will be the coefficient of A, and this will be D, A equal to D, and coefficient of IR and this VR, this coefficient will be equal to B, and this coefficient will be equal to C. We can see that AD minus BC will be equal to 1. If we multiply A and D and B and C, and their difference will be equal to the minus 1. Right? We have to remember this condition. For long transmission line, and also for short transmission line, A will be equal to D. A parameter will be equal to D parameter, and AD minus BC, their diagonal product of their diagonal and their difference will be equal to minus 1. And now considering surge impedance and surge impedance load. Characteristic impedance is defined as the square root of the ratio of the series impedance to the shunt admittance. जो सीरीज इम्पिडेंस Z था और शंट एडमिटेंस Y था, उसका जब स्क्वायर रूट निकालेंगे वो जो होता है YZ रूट YZ क्या था आपका कैरेक्टरिस्टिक इम्पिडेंस, सॉरी रेशियो है ना, जो रूट ऑफ series impedance, root of the ratio of the series impedance and shunt impedance was known as characteristic impedance of the transmission line, and it is a complex quantity. This is Z root of Z by Y. If we will put the value of Z, this should be to the R plus omega L, and Y admittance, this is the G, this will be to the G plus J omega C. You know G is the conductance and C is the capacitance and will be independent. If the line is lossless, when line will be lossless? When the resistance of the transmission line will be equal to 0, or the conductance of the line will be 0. This is the resistance of the series path, and this is the resistance of the shunt path. When it will be 0, then the transmission line will be lossless, definitely, because the losses occur due to the resistive part of the transmission line will be one region for the loss. Now the characteristic impedance is when line will be lossless, then this the characteristic impedance is known as the surge impedance. And surge impedance is the net impedance when the line losses become 0, and that is pure resistance and can be written as ZC will be equal to J root of J omega L by ZC. When we put the value of R equal to 0 and G will be 0, then it will become J omega C, J omega and J omega will be cancelled out. It will be equal to root of L by C, and it's denoted by Z0 or this surge impedance, right? Surge impedance or the characteristic impedance is independent of the length of the line. You can see from the formula, surge impedance Z0 is independent from the length of transmission line, right? Surge impedance loading. Now we have to be careful here. Surge impedance loading of line is the power transmitted when a lossless line operating at its nominal voltage is terminated with a resistance equal to the surge impedance of the line. Sorry for disturbance. If the transmission line terminated with the resistance equal to the surge impedance of the line, जब ट्रांसमिशन लाइन के एंड पे सर्ज इम्पिडेंस के इक्वल अगर लाइन कनेक्ट कर देते हैं, उस केस में जो पावर ट्रांसफर होता है, ट्रांसमिट होता है, उसको हम क्या बोलते हैं, सर्ज इम्पिडेंस लोड। मतलब ऐसा लोड जिसका इम्पिडेंस सर्ज इम्पिडेंस के बराबर है, तो उस केस में जो पावर ट्रांसफर होता है या उस लोडिंग क्या बोलते हैं, सर्ज इम्पिडेंस लोडिंग। Denoted by PSI will be equal to simply V square by Z0, where V is the operating voltage and Z0 is the surge impedance. And this is also known as the natural loading of the line, right? You have to be careful. Now these are the some conductor configuration and their surge impedance loading. You can see here for the highest or ultra high voltage 765 kV, its surge impedance loading is 2250. For the bad Smith configuration, and for the 66 kV For single dog conductor configuration, this circuit potential loading will be 10 megawatt. What does it mean? Uh, 66 kilovolt गेल. अगर ट्रांसमिशन लाइन का कन्फिग्रेशन सिंगल डॉग वाला कन्फिग्रेशन यूज हो रहा है तो उसके लिए जो सर्ज इम्पिडेंस होगा है ना कितना होगा 10 मेगावाट. इस केस में 10 मेगावाट क्या होगा जो ट्रांसमिट पावर हो लॉसलेस लाइन क्या होगी लॉसलेस राइट. To increase the power transmitted through the long transmission line, the operating voltage of the line can be increased. Either operating voltage will be increased or Z0. Yeah. Either Z0 will be decreased to increase the power transmission. Okay. Z0 can be reduced by either double circuit. Double circuit means there will be two transmission lines. Then for the you know that when two resistors are connected in parallel, then the equivalent resistance of that circuit will be get reduced or decreased. Double circuit line, which is very expensive, or by increasing the value of the capacitance, you know the value of capacitance. If you increase the value of capacitance, then it will decrease the impedance, series impedance of the line, or by decreasing the value of inductance. या तो इंडक्टर का जो सीरीज इंडक्टेंस है उसका वैल्यू डिक्रीज कर दें या कैपेसिटेंस रीच कर दें. दोनों केस में क्या होगा जो इंपेडेंस है आपका इफेक्टिव इंपेडेंस विल बी डिक्रीज्ड. नाउ वेव ऑफ द ट्रांसमिशन लाइन. Looking at equation 11.43, 11.43 means this one. This I have already declared that. This is the wave equation for the transmission line. Right? For the transmission, this is the two terms. There are two terms, A to the power x and B e to the power x. Represent the two wave of the voltage evaluated at the x meter. There are the two waves, A e to the power x, and the second term is B to e to the power minus gamma x. And this is the voltage evaluated. This is the voltage at distance x from the right hand side. Right hand side means receiving end, because receiving end was taken as a reference. That now the value of the A e to the power gamma x increases when you move from right hand to left hand, from receiving end to the sending end. When you will move, then this A to the power gamma x will get increased, right? And it has the highest value at left hand side or at receiving end, sending end, right? Now that term A to the due to which this term A to the power x can be considered as incident wave. Similarly, we can give the argument to the second term, and that will be considered B in e to the power x will be considered as the reflective wave, right? Because it will get decreased as x increase, right? Now the voltage equation can be written as Bs plus e to the power x plus Bs minus e to the power x. This is the incident wave. This will be the reflective wave. Now Bs plus this incident voltage can be calculated from this equation. Vs plus will be Vr plus IR Zc by 2. Vs minus equal to Vr minus IR Zc by 2. A line terminated with characteristic impedance is called the flat or infinite. When the transmission line terminated with characteristic impedance or ZC, then this line is on a flat or infinite. Flat means voltage profile will be flat. There will be no sag or swell in the voltage profile, right? And I will explain in next lecture this voltage profile or flat line. Now we have to be we have to remember all the important formula and concept on the important topic what I have declared. Okay, this topic is very important from the CAT point of view and engineering services point of view also. Okay, okay, thank you so much.